Oh, hello, and welcome to tonight's lesson. We're going to be learning about conduction, convection, and radiation, different ways energy can be transferred. We'll start with conduction. It's probably the first form of energy transfer you learned when you were a baby and you touched something really, really hot. Conduction only works because the atoms are packed closely together in something like a metal. What happens is the kinetic energy, because the atoms are packed so closely together, is able to move from one atom to the next atom to the next atom with relative ease. Conduction is probably not an energy transfer method we're going to use very often in earth science. What we have already talked about in earth science is convection. Convection is a transfer of energy by the motion of a fluid. Now this can occur in liquids and gases, and it's basically the hot air balloon effect. Why does a hot air balloon rise? Well, if you heat a gas or a liquid, it expands. When it expands, it becomes less dense. And when it becomes less dense, it becomes more buoyant and it rises. We see this in the mantle with convection currents and hot spots, which create volcanoes like Yellowstone in Hawaii. And we'll also talk about it in the atmosphere in the upcoming unit. This is what creates clouds and basically is responsible for all transfer of energy from the equator toward the poles. The last method of energy transfer is radiation. Radiation is how energy reaches the Earth's atmosphere from the sun through the vacuum of space. Now, this is energy that transfers in waves, and it can travel through anything that is transparent to it. Now, transparent means different things to different wavelengths of radiation. The wavelength is how far it is from peak to peak of a wave. We start on the very, very long end with radio waves and microwaves, and we go all the way down to very short wave radiation like gamma rays. Now what the sun gives off the most of is what we call visible light. It's not actually a shocker that the sun gives off most visible light, because your eyeballs are really just radiation detectors that have evolved to detect the radiation that is most common on the surface of the Earth, which is what the sun gives off. Now our eyes are able to detect millions of different color variations, but basically we break it down into Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. Is there really a difference between indigo and violet? Yeah, I guess indigo is. Is there a difference between indigo and blue? I don't know. Blue jeans are indigo, that's all I know. Anyway, back to radiation. When we talk about radiation in weather, we're going to be primarily talking about radiation from the sun, and then we'll talk a little bit about ultraviolet radiation, which is the wavelength a little bit shorter than what our eyeballs can detect, and infrared radiation, which is a little bit longer than what our eyeballs can detect.